Hello! So this is our first lesson for our quadratic functions unit. And so our learning target is to explain characteristics and identify a quadratic function. And we're going to go over specific vocab, maximum or max, minimum, and min, concave up, concave down, vertex, axis of symmetry, zeros, y-intercept, domain, and range. So obviously you've seen max and min before, we've done y-intercept before, domain and range before, and then we've talked about some of the others, and then we're just going to be more explicit with those. So, first up, remember expectations, use your time to pause, take notes, listen to me, make it faster if you need to, make it slower if you need to, and then we will end with our after stuff. I'll leave that up just so you can come back to the vocab when we're done. All right. So, I need my piece of paper. Where did they go? I just had them. So prepared. Okay, so somewhere in your table of contents, make sure that you are ready to go with your table of contents. And we're going to zoom in. That's not what I wanted. Let's just make you lower. And there we go. Awesome. And focus. So, in your table of contents, this will be your next page, and we're just going to call it Describe Quadratic Graphs. All right. And we need to refocus that because that doesn't work. There we go. All right, describe quadratic graphs. So we're going to do 3 examples, and then we're going to do 3 examples at the end as well. So we're going to have 1, 2, 3 that are about, I guess I should zoom out now. Ooh, make you nice and tall so you can see. So we have 1, 2, and 3. And then at the end, we're going to have 3. Oh, my heater's blowing me up. Okay, and then we'll have 3 mini examples at the bottom that talk about different forms and just patterns that you can see within those. So, for number 1, 2, and 3, we're going to be graphing. So if you want to take this time and sketch graphs for 1, 2, and 3, we'll be graphing on the left-hand side and then going over characteristics on the right-hand side. So, describing quadratic graphs. Our first one is going to be y equals x squared minus x minus 2. Second one will be y equals negative x squared plus 9. Third one will be, and I'll put this in function notation just so you see it that way again, 3x squared plus 5x minus 2. So these are the 3 graphs that we're going to graph. Now, if we look at our learning map, in the learning map, we have describe quadratic graphs as learning target 1, graphing as learning target 2, and then in a little bit, I will make the next video for writing quadratic functions, solving quadratics by graphing, factoring, and quadratic formula. And we'll be breaking this unit down into 2 pieces. But since graphing is its own learning target, that will be its own video. We're going to use Desmos instead to help us do this a lot quicker. And since graphing will be on its own, we can do Desmos. So go to desmos.com, click Graphing Calculator, and we're going to be typing these in. So the first one, y equals x squared minus x minus 2. Notice that to get that x squared, I hit Shift 6. That gives you that superscript, arrow to the right, so click that right hand arrow, and that will bring you back down so you can continue typing the minus x minus 2. Again, Shift 6 and arrow to the right. So this is what our graph should be, and in this little tiny corner off to the side, I'm going to be drawing it. I guess I'll shift this over. Okay, so for number 1, we're going to graph it. Notice that Desmos gives you points that we like, so you should have a coordinate at about a half, so I guess I'm going to go, I'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to go a half and down 2 1/4. So at a half, go down 2 1/4. Then I'm going to go to -1. And I'm going to go to +2. And yes, they have, oh, and this one has a -2. Okay, so there are only 4 points that are actually gray on this parabola. So we'll talk about graphing and how many points are helpful next time. All right, that's our first graph. On to the second one. So I'm going to actually just turn off this graph and I'll turn on the next one. The next one will be y equals -x² equals -x² plus 9. All right, so this is our next graph. I'm going to try to make my dashes a lot more thin. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Notice that I'm trying to make them equally spaced so that my graph is still nice. So there is a gray point up here at 0, 9. I have also a coordinate at 3, 0 and a coordinate at -3, 0. And then I will make that curve, make that U shape, that parabola shape, and put some arrows on it. And then my last one, notice that it is in function notation. Desmos does not like function notation. It thinks f is its own variable. So you do have to keep it as y when you write it in there. But they are the exact same thing. So again, looking at here, I'm going to have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so this x-intercept here is at about 1/3. Woo! This one's at -2. The y-intercept is at -2. And this is our vertex down here at almost -1, -4, but a little off. Okay. Whoop. Whoop. So this one is a little skinnier than the other two. I'm going to keep these 3 here just so you can go back and toggle to them, but I'm going to minimize this just so my screen has somewhat less that's working with. And we're going to go back up to number 1. So on all of these, we are going to be going over all those vocab words that we saw before. So we're going to go over, is it a max or a min? And where that location is going to be at. Is it concave up or down? Where's the vertex? And what is the vertex? What is the axis of symmetry? What are the zeros? What's the y-intercept? And what's the domain, and what's the range. So I'm going to pause here, and I want you to write all of this on all 3 sections. So there we go. Pause. All right, so for number 1, I put this all in plastic, so hopefully it saves me some time later down the road. So looking at our first one, I'm going to turn that first one back on. Turn the third one off. So is there a maximum or is there a minimum? Is there a highest point, there's no other point above it, or is there a lowest point, there's no point below it? So in this case, there is a minimum. So I'm just going to circle minimum. And in that minimum, if we look at Desmos, it will tell us that minimum is at 1/2, -2 1/4, or you can write the decimal down. And is this opening up, concave up, so it's a smiley face, or is it concave down, so it's a frowny face? This is actually all going to be up, so it's concave up. Vertex is actually going to be the exact same thing as the max or the min, so I'm just going to rewrite that as 1/2, -2 1/4. Axis of symmetry. If we notice parabolas, they're symmetrical. There's a line down the middle that I could write and fold each half onto it. So if I look at that, that is going to hit right on my vertex every single time because that vertex is in the exact middle. So the axis of symmetry we write as x equals 1/2. When you draw a vertical line at x equals 1/2, you'll be cutting that parabola in half exactly. So the left side would match the right side. Zeros are also called roots and also called solutions. We're only going to write out those words on this one just for the note's sake. But those zeros, roots, and solutions, those are all x values. So I have zeros at x equals -1 and +2. So I just write that as x equals -1, comma 2. The y-intercept is also labeled for us on Desmos. That will be 0, -2. That's where it crosses the y-axis. And we've done domain and range before, so thinking about this domain, is there any value, is there any value that's not able to be plugged into this function? Could I use -infinity? Would I be able to get a value out? Yeah. +infinity? Yeah. So domain is going to be all reals. And actually, it's going to be all reals for all of these. But the range will be something special. So if I turn my paper, notice that I have the least values of y to the positive, the highest values of y. So the smallest value is at -2.25. That's included and all the way up to +infinity. So my range is going to be including -2.25 all the way up to +infinity, not included. So this is our first example done. So if you want to try the second example, pause here and then we'll go over it. So second example, it has a maximum. Again, this is the same location as the vertex. So if I turn this one off, turn this one on, okay, the maximum should be at 0, 9. That's also going to be our vertex. Notice that because it's a maximum, this will be concave down. When we had a minimum before, it was concave up. The axis of symmetry, if I cut this in half, would be at x equals 0. Notice it's always an x equals because it's a vertical line. 0 is where does it cross the x-axis? These are also called x-intercepts, so -3 and 3. The y-intercept is actually the same thing as our vertex this time, which is cool. Domain, like I said before, will be all reals because I can go from -infinity to +infinity. The graph will still be a graph. So you could write this also like that, -infinity to +infinity, or the fancy R for all reals. The range, if I rotate my paper, I go from -infinity as the smallest value of y up to and including 9 as the highest value of y. So I'm going to have -infinity up to 9 inclusive. So this is example 2. All right, turning that one off, turning the next one on. Example 3. Pause here to do it on your own. I'm going to pause my video and do it as well. All right, here's example 3. Notice there's a minimum. It is the smallest point. There's no maximum in this case because there's always a point that's higher. And then it's concave up because we have a minimum. The vertex is at that location, same thing as the minimum. The axis of symmetry is the x value of that vertex. The zeros are where it crosses. That'll be -2 and +1/3. Y-intercept is at 0, -2. Domain is all reals. Range includes and starts at -4 and at 83/10,000ths and goes up to +infinity. So those are our 3 examples. Which part stumped you? Which questions do you have? Put a comment in this video. It'll email me so I can reply to that comment. And then the last piece is going to be A, B, and C. I want you to wonder about this. So there's my stuff. Okay. So I want you to wonder. We have y equals x plus 3 squared minus 1, y equals x squared plus 6x plus 8, y equals x plus 4, x plus 2. So as an extension, and I would like you to do this, it's not just an optional extension, as an extension of the notes, I want you to put these 3 functions into Desmos, see what you see. What are the y-intercepts? Is there a maximum or minimum? Is it concave up or concave down? What is the vertex? What's the axis of symmetry? What's the domain? What's the range? How are these all related? Are they similar? Are they different? What makes them similar? What makes them different? What are some things that you have stirring in your mind? And then bring those questions and observations to class. So again, as a refresher, these are the vocab that you should know. max, min, concave up, concave down, vertex, axis of symmetry, zeros, y-intercept, domain, and range. What questions do you have? What stumps you? Which one like totally tricked you that you're like, okay, I really need to figure out domain and range again. Like, what's that Desmos that we did before? Or what's the vertex? Or how do I find that? So we're going to build on this information. Bring your questions to class. This is your time. Make it worth your while. All right. Have a great day. Bye.